I just had to get a book and just read from the book. All right, so here's our whole number section. Go ahead, I think I turned on the recording, did I? Yeah. And we'll start with this today. I'm going to try and pull up my handy dandy. Okay, it's on transparency, so that'll work. And slideshow from beginning. All right, now we all know what whole numbers are. I'm not going to insult anybody's intelligence by going over whole numbers because most of y'all know 75% of this section. All right, this is 5.1, I think, and I'm not going to spend a lot of time on it. There are some sections that I will spend a lot of time on, and I'm going to tell you what you should know. That's when you don't raise your hand and say, "You're talking about me." Okay, don't raise your hand. When I say that a student needs to be able to do this, this, and this, that's not when you raise your hand and say, "You're talking about me." Okay, you keep your mouth shut. What you need to do is take what I'm saying, go home, and fix it if I tell you that you need to do something. All right? Whole numbers. Now, I'm not going to spend a lot of time on the place value. I'm not going to do that. It's supposed to be working. It's not working. There we go. I'm not going to spend a lot of time on place value. I'm not going to spend a lot of time telling you where the place values are because I would assume that most of you know where the place values are. I assume that most of you know how to rewrite 35 into the place values. I'm not going to spend a lot of time there. I will talk about this because this is one of your weaknesses. All right? It's called the additive table. The additive table gives us the subtractive table. 3 plus 8 is 11. 11 minus 8 is 3. 11 minus 3 is 8. If you're doing this, you're in trouble. Okay, I'm telling you that right now. You do this, you're in trouble. So you need to fix it. How do you fix it? You go home, you write down the tables if you want to, make a spreadsheet table if you want to. You got to learn it. Now, if you see, there's a pattern. There's a pattern in here if you see it. If you don't, then don't worry about it. But what I want you to learn is that 3 plus 2 is what? 5. 5 minus 2 is 3. 5 minus 3 is 2. A lot of people don't realize how important the additive table and the multiplicative table is. Because I got people now, I bet you in this room, that if I asked you what 5 times 6 is, some of y'all have to sit there for 3 or 4 seconds and remember. 5 times 6 is 30. 30 divided by 6 is 5. 30 divided by 5 is 6. You shouldn't be going, 5 times 6 is 30. You shouldn't be doing that. Because when we get to the prime factorization and we get to the least common multiples and the greatest common divisors, you're going to have to be able to divide and you're going to have to be able to add and subtract. And I can't ask you to do that if you're still doing this. All right? So, one homework problem tonight for you is to go home and make an additive table and a multiplicative table and make sure you know how to use it. Make sure you know how to do the opposite. And if you don't know your multiplication tables, and don't think I'm not talking to some people. There are some people that have gone through 12 years of high school and are in their first year of college and they don't know what 6 times 8 is. And then they wonder why they can't do math. Well, they can't do math because they don't know the basics. So, first 2 things that you need to learn are these 2 tables. The additive table and the multiplicative table. The higher you go, the better off you are. I usually tell students to go to 15. Okay? That's what I tell them because most of your college books are thinking that you know your multiplication tables up to the 15th. 15 times 15 is 225. 14 times 14 is 196. And if you look at the the multiplicative table, you don't have to memorize. All you've got to learn is how to count. How to count by twos. 2, 4, 6, 8. 2, 4, 6, 8. That's 4. 2 times 4 is 8. 5. 5, 10, 15, 20. 4 times 5 is 20. You don't have to memorize. All you have to do is count by the numbers. A lot of people have gone through mathematics and have gone through elementary education trying to memorize their times tables. You don't have to memorize your timetables. You just have to count by the terms. Threes. 3, 6, 9. 3 times 3 is 9. 12, 24, 36. 3 times 12 is 36. You see what I'm saying? And a lot of people spend, how many of you have spent probably a total of 2 or 3 days trying to memorize times tables? I did. And some people still haven't learned them. But if you just look at the pattern. Zeros, well, 0 times anything is 0, okay? Look at what you're doing with the ones. What are you doing as you go down? Count by ones. What are you doing by the twos? Huh? Count by twos. What are you doing by the 11s? What are you doing by the 14s? So all you got to do is be able to count by 14. 14, 28, 30. I'm not used to counting by. I can do the multiplication in my head. I'm not used to counting by 14. But people that have never learned the tables, you just have to learn how to count by the multiples. If you learn how to count by the multiples, you have your multiplication tables. And eventually, after you do them in your head so many times, you're going to learn to do them without saying 3, 6, 9. 3 times 6 is 9. So, for those of you that need it, your first 2 homework equations, your first 2 homework problems is to learn these 2 tables, or to refresh yourself on these 2 tables. Because everything that we're going to do in the next 2 or 3 sections is going to be based on how well you know these things. And if you know how to multiply, then you know how to what? Divide. 72 divided by 9 is 8. 72 divided by 8 is 9. Now, a lot of you are saying, well, Hubert, I know those. Yeah, but do you know how to use them? Like, for instance, I've seen so many students that can tell me that 9 plus 5 is 14, but I ask them what 29 plus 5 is, and they have to do this. Well, if 9 plus 5 is 14, what's 29 plus 5? 34. Okay? You'd be surprised on how many students, and I'm not talking about y'all, I'm talking about all students. They'll learn the additive table, and they'll say to themselves, 5 plus 3 is 8. Or 5 plus 9 is 14. But when they do 29 plus 5, they'll count on their fingers. It's the same thing. You've got to learn how to use these tables to your benefit, not to your disadvantage. And there are so many students, you would not believe how many students I have tried to teach how to do basic fractions, and they don't know how to do this. And they don't know how to do the multiplication tables. You can forget fractions because you don't know how to convert, because you don't know how to multiply and add. And if you don't know how to multiply and add, you don't know how to divide and subtract. So you've got to learn these 2 tables, okay? That's all I'm going to say about that, because if you don't know them, if you're counting on your fingers, then you're going to have problems. Okay? So nobody raise their hand and say, I do that. Okay, the next thing we're going to talk about is prime numbers. Now I want you to write this down. That's at the top. What are prime numbers? Prime numbers are those ugly numbers. The ugly numbers nobody likes to deal with. Why? Because they're only divisible by themselves and 1. Prime number definition. They're only divisible by themselves and 1. Now most of them, I will grant you, are odd. Most of them are. And if you take 2 out, you could say all of them are odd. But you can't say that because there's a lot of composite numbers that are odd. 9 is odd, but it's a composite number. Why is it a composite number? Because more than 9 and 1 will go into it. As she said, 3 will go into it. The ugly numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23. What comes after 23? 29? Something like that. 29, then 31, then 37, then 41. I'm thinking off the top of my head, just ugly numbers. Numbers that are only divisible by themselves in 1. Oh my, if I don't know my multiplication tables, I don't know what's divisible. See? You got to know your multiplication tables, and then you know your division tables. What are composite numbers? Composite numbers are all the other numbers. I don't even know what composites are. Oh, there they are. 4, 6, 8, 9, 10, 12, 14. In other words, these numbers are divisible by other numbers. Okay? Not just themselves in 1. Now, when I ask you to factor something, you may think that I'm thinking of algebra. No, you can factor a number. Factor is a 25-cent word for break it up. All right? And I usually use the number 54. There it is. I say I did. No matter what when I teach, I always use 54 for some reason. Just like when y'all think of a number, you think of a certain number. Well, when I think of factoring, I think of 54. Because if I asked you to break up 54, 9 out of 10 of y'all are going to say 6 times 9. Why? Because you know your multiplication tables. Now, one person in the back of the room sitting in the corner is going to say, well, you could say 2 times 27. Yeah, you could. All right? But nobody thinks in terms of 2 times 27, except the little person sitting in the back in the corner that doesn't think in terms of everybody else. All right? So 6 times 9 or 9 times 6 is what you come up with. You have just factored that number. You have just broken it up. Now, there's 2 types of factorization in whole numbers. There is the factoring, which is regular numbers like 6 times 9. And then there is the prime factorization. Now that's what we're going to focus on today, is prime factorization. We're not going to focus on composite, because y'all should know your multiplication tables, and if I asked you to factor 27, you're going to say 3 times 9. Or if I asked you to factor 24, you're going to say 2 times 12. Or you're going to say 6 times 3, or 8 times 3. Or you're going to say 6 times 4. So I'm not worried about you being able to factor in a regular composite way. I want you to factor in a completely different way, which is prime factorization. And it's based on those 5 numbers that are highlighted there in the top. Now you could use 17, 19, 23, you can, but most of your numbers, 95% of your numbers are going to be divided by those first 5, one of those first 5 numbers. Okay, or 6. All right, 2, 3, 5, 7, 11, and sometimes 13. Sometimes I like to say, remember A, E, I, O, U, and sometimes Y. Well, this is the counterpart to English with the vowels. This is 2, 3, 5, 7, 11, and sometimes what? 13. Most of the time, one of those numbers is going to go into your number. Now, I want to show you something else that I want you to learn. I didn't put it on the slide, but I'm going to show it to you, and you can Google it. And I want you to Google it. It's called the Divisibility Test. So you go over to your handy dandy Google and pull up. Let me get Google pulled up, or whatever I've got in this little Firefox or whatever. I want you to pull up Divisibility Test. And you can just do images. And there's your divisibility test. I want everybody, if you want to write it down, that's fine. I should have put it on the slide, but I'm sorry, I suck. Hold on, I'll fix it. Copy image. Do I want to copy image? No, I want to save image. Save image, test of divisibility, blah, blah, blah. I'm just going to call it divisibility. And divisibility test. And I'm going to hit save. I'm going to go to my handy dandy PowerPoint. Or is it whole numbers? I don't know why I've got two of them pulled up. And how do I go back? Display settings. Y'all just hold on a minute. Be with you in just a minute. In slideshow. I was hoping it was going to take me back to where it is. And I will put that right in here. And I'll insert. Slide. And insert. Bear with me for a minute. Insert picture. Oh gosh, where did it put it? Didn't put it there. Downloads. There it is. I know, y'all were impressed, I know. Alright, there you go. So now we got it in there, and we hit save. And hopefully it'll save it. Okay, whatever, just save it. Yes. Revised one, how about that? There. Slideshow and slide. Alright, so there's the divisibility test, and just take a look at it. It says that if you have a number that ends in either 0, 2, 4, 6, or 8, then it's divisible by what? 2. If you have a number where the sum of the digits added up and it's divisible by 3, then that means that number is divisible by what? 3. Number formed by the last 2 digits, if they're divisible by 4, then the whole number is divisible by 4. Last digit must be a 0 or a 5, that means it's divisible by 5. If the last number is 0, that means it's divisible by what? 10. Some of you never seen this before. Some of you may have. You need to print that out, or you need to get it off of Google, print it out, put it on an index card, and start looking at it. Because that'll save you a whole lot of time when you're doing the prime factorization. Now, I don't do that. I use 2, 3, and 5. Most of the time, 2, 3, and 5 will go into a number. 2, 3, or 5 will go into a number, usually. I just like using 2s and 3s if you want to trick about it. And you could do that if you wanted to. But why do I not want to use 4, 6, 8, 9, and 10? Because those are composite numbers. So you need to highlight 2, 3, 5, 11, and you need to remember those. Okay? Y'all just learned so much today, aren't you? Y'all just real interactive today, too. Okay, I hit the arrow. That means go. All right, so here is how we do prime factorization. We draw there's the number 54, and I want you to find the prime factorization of 54. So you draw across, and you draw the ones across as we go. Draw the top one under 54. And then you say, okay, what goes into 54? Does 2 go into 54? Yeah. Does 3? Yes. No. I don't think it does. No, it doesn't. No, it doesn't. Okay, so, yeah, it does. So you can use 3 or 2. Which one do you use? It doesn't matter. Because multiplication is commutative. 3 times 2 is the same as 2 times 3. So it doesn't matter how you multiply the numbers. Yes or no? No. So you can start with a 2 or you can start with a 3. I usually start with 2 because it's easy to what? To divide. To me, 2 is the easiest number to divide into any number. 2 into 104, 52 times. To me, 2 is easy. So I use 2 a lot. So 2 will go into 27, 54, how many times? 27. So you bring that 27 down. Now, what's divisible into 27? 2, 3, 5, 7, 11, or sometimes 13? 3. 3 will go into 27 9 times. What's divisible into 9? Everybody knows that. 3. Divide by 3, and then divide by 3, and look at that 1. When you get to that 1 that's highlighted right there, that means you're what? You're done, and your prime factorization is on the right-hand side, left-hand side. So your prime factorization is 2 times 3 times 3 times 3 times 3. Or 2 times 3 to the what? Third power. Okay, 48. 48 is an even number, so you divide it by 2. 2 will go into 48 24 times. 2 will go into 24. I'm sorry, 3 will go into 24 8 times. 2 will go into 4, 8 4 times. 2 will go into 4 2 times. 2 will go into 2 1 time. Again, we have the 1, so that means what? We're done. And your prime factorization there is 2 times 2 times 2 times 2 times 2 times 3, or 2 to the 4th power times 3. Now remember, the composite numbers do not exist in these problems. So when you say, if I say, well, let's do 54. What goes into 54? Somebody says 6, you're missing the train. All right, you done missed it. You're missing the boat and the train. I didn't say anything about composite numbers. This is prime factorization. You've got to be able to use prime factorization in order for us to find our common denominator here in the next couple of sections. All right. Hopefully we have a page after this one. I can't remember where we... Okay, we don't. So that's when I go here and I pull up my handy dandy board. Okay, there we go. And we're going to do a number as soon as I can get this thing to work. Okay, well then go away then. There. Okay, well, slideshow's not running anymore. Go away. I guess I'll have to exit the slideshow to get... Okay. Now, can I have my class back? Evidently not. I didn't have that trouble this morning. There we go. Sorry about that. So let's take our handy dandy text and let's go ahead and let's find the prime factorization. Find the prime factorization of, let's go with something simple like 32. And then after you do 32, I want you to do 81. And then after 81, I want you to do 136. And find the prime factorization of those three numbers. Just separately. Do them separately. Don't do them together. That might cause a problem. Oh, we're not going to erase this. Okay, whatever. So, 32. Now, sometimes I would go ahead and I put 2, 3, 5, 7, 11, and sometimes 13. Sometimes I write them up there just to remember and just to reiterate that I'm not going to use my composite numbers. So, this is where your division and your multiplicative skills come in. If you suck at it, then you're going to know. So, 2 will go into 32 how many times? 16. 2 will go into 16. 8. 2 will go into 8. 4 times. 2 will go into 2. 4 2 times. And then the last one, 2, will go into 2. 1 time, we got the 1. So therefore, this is our prime factorization. So 1, 2, 3, 4, 5. So 2 to the 5th power is equal to 32. And that's called prime factorization. Simple as that. Yeah. All right, let's try 81. So I'm not going to start with 2 this time. Why? Because 2 won't go into 81 because it ends in a 1, so that means it's odd. So chances are you might have better luck with a 3. So divide by 3. And see, this is where your division comes in. 3 will go into 8. Okay, we do it in our head. 3 will go into 8 2 times. 2 times, that's a 6. 8 minus 6 is what? 2, 21. 3 will go into 21, what? 7 times. Now what I did in my head is I did my long division in my head. That's something you need to be able to do. Now a lot of you are saying, why do you need to be doing all this stuff? What are you doing to your brain while you're doing this stuff? You're kicking off things in your brain that you haven't been using in a while. So you won't be that person at the cash register that can't make change. All right? You're firing off some things in your brain that haven't fired off in a while. So what will go into 27? 3. There's no 9 up here. Remember? 3. I know what you're doing. 3, go in there 9 times. And then 3, go in there 3 times. And then 3, go in there 1 time. We've got our 1. So our answer is 3 to the what? 3 to the 4th power. So your prime factorization for 81 is 3 to the 4th power. No sneezing in class. Okay? And now try 136. Now you know this is divisible by 2 because why? It ends in 6. It's even. Now, one thing that I would suggest you do tonight is when you go home, do these about 500 times. I'm exaggerating, but you can make them up all day long. And check them. I don't tell you to use your calculator right now, but if you wanted to check your calculator, take your calculator after you get through and you say, take these numbers right here and multiply them together and see if they equal the top number. That's the only reason you should be using a calculator, is to check. So, divide by 2. Okay, 2 will go into 13 6 times. That'll leave a 1 because 13 minus 12 is 1. 1 and 6 is 16. 2 will go into 16 how many times? 8. And that's what you should be doing in your head. Alright? How many times will 2 go into 68? Well, that's easy. Half of 68 is 34. Can you divide 34 by 2? Yes, 17. Uh-oh. 17 sucks. That means 17 is a what number? Prime. And you're done. So your prime factorization for 136 is 2 to the third power times 17. So you should be able to break any number up into its prime factors. Now you're going to see why this is important when we get to 5.3, which is fractions, or 5.2, I can't remember. Okay? Just trust me. There's three things that you need to be able to do. One is your additive table, two is your multiplicative table, and three, you should be able to find the prime factorization. That should be in 5.1, those are the things you need to be working on, those three things. Now the next part is finding the greatest common divisor. Really, I had to do beginning, didn't I? Well, that's okay. Now, here's the. I always get the names mixed up. I can't remember which one is which. I think it's the least common multiple. I can't remember, but anyway, there's two numbers I want you to be able to get from your table. That one of them is the greatest common factor, the other is your least common multiple, and I think I got them backwards. I can't remember. I always forget. But one is the smallest number that will go into both numbers, and the other one is the important one. The big number is the important one. That's your common denominator later on. So, I think it's greatest common factor. I think I got them turned around. If I do, I'm sorry. I always do. So, let's take these two numbers right here. 54 and 104. And I put them on the scale here, and I draw a table, and I do my first one. 2 will go into 54 27 times. And 2 will go into 104 52 times. Now at that point, I put RMS out here. Why is that? Because the real math stops. What do you mean the real math stops? Well, give me a number that will go into both 27 and 52. One, 2. 2 won't go into 27. All right. Well, 3. 3 won't go into 52. See what I'm saying? In other words, there's no other numbers that will go into both. You might find one to go into one and one to go into the other, but there is no number except for 1, which doesn't help us because it's multiplicative identity. It doesn't help us. So 2 is your least common multiple, I think. I think it's your least common multiple. I can't remember. Somebody look it up in the book. All right? I'm sorry. That's one thing that I always get mixed up in math is which one's which. So you need to find it in your book. You'll find it. If somebody find it, shout it out, okay? This is the biggest number that will go into. I screwed that up, didn't I? I'm used to writing on that. Sorry. That is the biggest number that will go into 54 and 104. Both. The biggest number that will go into both those numbers is 2. Now that's really not important to us right now. What's important is the other guy. And I think it's called the greatest common factor. So you keep going. Now what I mean you keep going is if something is divisible, you do it. If it's not divisible, you just bring it what? You bring it down. So watch what I do here. 3 will go into 27 9 times. 3 will not go into 52, so what do I do? I'll bring it down. 3, in other words, I'm trying to annihilate one, and then I'm going to annihilate the other one. Because I'm switching from one to the other. I'm going to get this one down to 1, and then after I get that one down to 1, I'm going to focus on the other one. Did everybody see that? So I'm going to focus on the 27. I'm going to divide by 3. 3 will go into 27 9 times, that comes down. 3 will go into 9 3 times, that comes down. 3 will go into 3 1 time, boom, I got my 1. Now I'm going to focus on the 52. 3 will go into 52, or 2 will go into 52 26 times. 2 will go into, or 3 will go into 26. 2, that's supposed to be 2. My mistake. 2 will go into 26 13 times. That's supposed to be 2. And then 13 will go in there 13 times. So my final answer, my greatest common factor, did somebody look it up, is the smallest number that both 54 and 104 will go into. So I need somebody to recalculate this number because I don't think it's right. It's 13 times, let's see how many 2's we got. That's 1 2. That's supposed to be a 2, sorry. That's supposed to be a 2, so how many 2's we got? 1, 2, 3. So 2 to the third power times 1, 2, 3. 3 to the third power times 13. And I think I got too many 3's up there. So somebody do that for me. 1, 2, 3. 2 to the third power times 3 to the third power times 13. What do you get? Okay, y'all not going to talk to me. Well, y'all got calculators. I know you know how to spin them around on your fingers like a dadgum basketball. I'll do it. That's all right. What was that? It sounded like a dog. Get that nasty thing out of here. I don't know. 2 to the third. I think it was 2 to the third times 3 to the third times what? Okay, so there's only 2. No, I had 3. 3 to the third times 13. 2808. Is that what y'all got?
8 times 27 times 13.
Yep. No, yep. 2808. So that one was incorrect. I'm sorry. So the greatest common factor, if y'all not looked it up yet, the greatest common factor is 2808. And since y'all are doing such a good job looking it up, I'll look it up myself. Let's see, I need to go to, I guess I need to pull up another, there we go. No, I got it. Appreciate it though. No, that's okay, I got it. What section are we on? 5.1. Come on, you can do it, come on. Alright, let me shrink this down where I can see something. There's the greatest common divisor right there. But they don't, let's see, determine, blah, blah, blah. I need to see a problem. I don't need to see that because they confuse me when they're very easily to confuse. There we go. That's not what I want. Bear with me. Okay, they don't give us anything else. Oh, that's pretty slack. Okay, find the least common multiple. Least common multiple is 270. So that's the, okay, so I wasn't, yeah, least common multiple, I'm right. The greatest common divisor is the smallest number, so I was right. Okay. Yeah, this is the smallest number that will go into them, I think. Yeah, 45, that's right. So I think I'm right. Smallest natural number that is divisible by each element of the set. Why can't they speak in English? I don't know why they can't speak in English. But that's what the least common multiple is, yeah. That's right, I was right on my slide, that's right. And the greatest common divisor is the largest that divides into that set. So that'll be a small number. Okay, so let's do another one. This time I'm going to do it on the board where I can draw something. There we go. So let's do two numbers. Let's do okay, that's interesting. Why is it not? Oh, I got that frozen. Oh. It's Bush's fault. Let's do this, source search. That's not what's on my screen. I don't know what to do. That's not what's on my screen. Can y'all see the mouse move? Y'all see it? No, okay. It's having a brain bubble because, is that? Give me a second, I'll figure it out. Okay, the slideshow is running. It won't let me get out. It won't let me do anything. Okay. Let me change this to mouse. Let me get out of this. Okay, we got something moving there. There we go. Now we're cooking with peanut OIL. Except now I can't get the whiteboard back up. It's like I say, it's. Let me get rid of this. I'm supposed to have a. There we go. All right, we fixed. So let's do 54 and 104. Oops, I said 105. I'm sorry, something's going on with this computer. 54 and 104. All right, go to it. Because my laptop at home is like got a screen the size of this screen. It's like huge, you know. I'd like to have something like that, and I can't use a tablet. Well, that's fine. I just can't stand to use a tablet because I can't stand to type on the screen. Okay, if you can't do this, just consider yourself a failure and you should quit school. Okay? You can probably leave if you want to. You get stuck, 2, 3, 5, 7, 11, and sometimes 13. So what goes into both of these? 2. And that gives you 27 and 50 what? Now at this point, the real math stops because 3 won't go into 52. And 2 won't go into 27. So that's your greatest common divisor. Least common multiple, we got to keep going until we get all what's on the bottom. 1s. So take your pick, 27 or 52. Somebody pick one. 27. So I'm going to focus on it and just bring this one down. Did we do this one?
Yes.
You are kidding me. I'm sorry. I'm sorry. I didn't even know we did this one. 9 and 27 or 52. 3 and 52. It's kind of hard to concentrate when the writing comes 2 or 3 seconds after. So you'll just got to bear with me. 1 or 3 and 1 and 52 comes down. Then we focus on the 52. And that's going to be 2 or 2 and 26. 2 and 13. And 13 will give us a 1 and a 1. And I'm sorry we did the same one again. So 3, 3, 3. So that's 3 to the third power, 2 to the third power, and 13. So 2 to the third times 3 to the third times 13. And I think we did, that came out to be what number? I did it on the calculator for y'all. 2808. Now let's do another one. Let me check something right quick. You gotta remind me what time is 2:10, 2:15, class is over? 2:10. All right, let's do one more because this is very important. So let's do $100 and $235. All right, find, I don't care about the least common, the greatest common divisor. I want you to find the least common multiple. 2, 3, 5, 7, 11, and sometimes 13. Quit. If you don't like word problems, quit. It's easy to quit, just drop. I know I'm kidding, right? Don't go home and tell people that I'm trying to get you to quit school. Probably 63. All right, right off the bat, I can divide by what? 5. That'll give me a 20. And 5 will go into 20 4 times. That'll leave a 3, 35, 7. Now, chances are at this point, the real math stops, but I don't care because I really care about the greatest common divisor. So I'm going to focus on the 20. So give me a 5. That'll give me a 4. And a 47, and then 2 will give me a 2 and a 47, and then 2 will give me a 1 and a 47. 47 is not looking too good because 47, I don't know if anything's divisible in 47. 47 may be a prime number. I'm thinking 36 is composite. 37, 38 would be 19, so no. 38, 39 is 39. I think 39 is divisible by 13. So it's composite. 40, 41, 41 is prime. 42 is not. 43 is prime. 47 is prime. So just bring it down. Unless you've got a number that will go into it, I don't know. So somebody take, let's see if I can do this, because there's a 10, ooh, look here. There's a 10 right there, and there's a 10 right here. Now why am I picking out the 10s? Because anybody can multiply by 10. You don't need a calculator to multiply by 10. If you use a calculator to multiply by 10 and I catch you, I'm going to take your calculator and I'm going to give it to somebody in the parking lot. Okay? Why? Because all you got to do is add a 0. Now, you could also take 10 times 10 and multiply it by 100, right? And that's 100, right? And then multiply 47 by 100. 4,700. Or you could take 47, multiply by 10, you get 470. 470 times 10 is 4,700. So what's the answer? 4,700. So your greatest common divisor is 4,700. Now, before I end class today, I want to show you where we're heading with this and why the additive, the multiplicative, prime factorization, and finding the greatest common divisor or least common multiple, those 4 things are so important. Let me mess my computer up again. But I took the time to do these PowerPoints. I just really want to, I'm really proud of them. I'm kidding. Let's see. What's that one? That's not it. Oh well, I didn't include it on this one. Well, I can put it right here. I'll just do it. So let's take this guy right here. Let's just take this one we just did, and I'll take my handy dandy shrinker and I'll shrink it down. And I'm going to put it over here. This computer is like running like it's got marbles in its processor or something. I don't know what's wrong with it. And I can't move anything because I can't All right, I'm just not going to worry about it right now. Now, let's say that I give you a problem like this in the next section of fractions. And I say that I'm going to do 3 over 100 plus 7 over 235. Now you see those two denominators? Those two denominators are these numbers right here. And I've got to find a common denominator for both of them. The least common multiple, guess what it is? Is equal to the common what? The common denominator. So if you can find the least common multiple in 5.1, then you can find the common denominator in 5.3. And that's very important because some of y'all are like I was when I was coming out of West Side. I didn't know how to add fractions. Okay? So, what's the common denominator of 100 and 235? Thank you for your interaction. I appreciate 1 out of 30 people. Thank you. 4,700. What? 1,700.
You said 30 people, I said there's 17.
Don't be quiet. You're being such a wife. Okay, 7 and 4,700 here. Now what do you have to do after you find the common denominator? You have to convert the what? The numerators. Now watch this. This is really neat. How many times will 100 go into 47? Well, let's say you have no idea. Take out the 100. How many times? 47. 47 times 3 is 161. Somebody look it up. I think it is. Somebody multiply 47 by 3. What do you get? Or 141. Is it 141 or 161? Huh? Use your calculator. 47 times 3. What is it? 141. Okay. How many times will 235 go into 4,700? Oh my. We got to think. 235. Where's 235 up here? Well, 235 is 5 times 47, right? So how many times will 235 go into 4,700? How many times? 50 times, Hubert. Yeah, that's right, class. Or 5 times. 20? Sure. Okay, I'm sorry, I must have got mixed up. Oh, I know why. I forgot. This is 4,700, not 47. That's mine. I'm sorry. 20 times. And 20 times 7 is what? 140. And now, what's 141 plus 140? 281. Now you see why it's important for you to know how to do multiplication, how to do division. Now, this is something we're going to do Wednesday, okay, or Monday, whenever y'all come back, okay? Whenever y'all come back, we're going to work on this. But you see why you have to find the least common multiple. If you don't know how to find this guy, you're going to what with this? You're going to suck at this. And if you suck at this, you're going to suck at a lot of things in algebra that having to do with the rational function. Because this is a rational. Ration means fraction. Capiche? All right. Now that this computer is about hitting the miss, I think I'm going to shut her down and stop the video before it completely goes haywire.